We've already solved some baby exponential equations and some baby log equations. Let's make some harder ones happen. So here's the procedure. First, we have to isolate the exponential expression. That's this. We have to isolate the exponential expression. That's this. So if you remember back in example 0, what I did is I divided both sides by that 0.00000 whatever. And when I divided both sides by that, if you remember, what I got was this big number up here, 3.982 times 10 to the 12th. And on the right-hand side, all we were left with is 2 to the x power when we divided both sides. That was step 1. Step 2 is to take the log of both sides. And now you could do the common log, the natural log, any log you wanted. We need to take the log of both sides. For me, I think log base 2 of both sides makes a lot of sense because we have an exponential with base 2. So if we take log base 2 of both sides, we get log base 2 of this number. A huge, huge number was log base 2 of 2 to the x. Step 2, check. Step 3 says simplify with properties of logs. How can we simplify this right-hand side? These undo each other. Logarithms undo exponential functions as long as they have the same base. This right-hand side is just exactly x. If you took the common log of both sides, you could still simplify that right-hand side. If you took the common log, how would this right-hand side simplify? With our exponent property. This is x times the common log of 2, and the common log of 2 is just a number, so we could get x by itself that way too. And so yeah, now we've simplified with properties of logs. So solve for the variable. Oh, we've already solved for the variable. We're good to go. We just need to approximate and say what is the common log, or what is log base 2 of that huge number? Let's use Desmos. What is the common log, or log base 2 of this big number? 41.8565. The inside, this is such a huge number. But the log is only about 42. And remember I told you in the last section, if you take a piece of paper, this is the same paper I used, you fold this piece of paper in half 42 times somehow, which is not possible. But if you could fold it in half 42 times, you'd reach the moon. You'd overshoot the moon. You'd go past the moon. All right. So that's one way how we could shoot this. Solve this. Let's do a more normal example. Also referencing something from the last section, solving exponential equations. If we look at the population of India, and we can model it by this function, where x is the number of years after 2023, and f is the population in billions, lots of people in India, when will the population be 1.6 billion? Remember, the population is our f, so when is f 1.6? Replace the f with 1.6, we got to solve this equation. How do we solve an exponential equation? Let's uncheck these checks and go through. Step 1, isolate the exponential expression. We need to isolate this part. This part is getting multiplied by 1.408. So to get this part by itself, we need to divide both sides by 1.408. Now the left-hand side is going to cancel. Sorry. The right-hand side is going to cancel. We just have 1.008 raised to the x power. What is the left-hand side? Let's use a calculator. 1.6 divided by 1.48. Oh, 408. About 1.1364. It's really best to keep it as a fraction and keep an exact answer, but let's not worry about it too much. That was step 1, Our exponential expression is by itself now. This exponential expression is the only thing on this side of the equation. Next, we take the log of both sides. In the last one, I chose log base 2 because our base was 2. We're not going to take log base 1.008. We actually could, but nobody ever does that. So we could take the common log, the natural log. We could take log base 5. You could take any log you want. Any log. Let's ln both sides. The natural log of 1.1364 equal to the natural log of 1.008 to the x. Great. We've natural logged both sides. That was step 2. Check. Simplify with properties of logarithms. How does that right-hand side simplify? We know that if we have the logarithm of an exponential, that exponent comes all the way in the front of this logarithm. The left-hand side, we leave that alone for now. The right-hand side is x times the natural log of 1.008. That was that exponent property. Great, we simplified with properties of logs. Check. Last step was to solve for the variable with algebra. So this is just x times some number. How do we undo multiplication? We want the x by itself. We're going to divide by that number. The natural log of 1.008 is just some number. And now we have x by itself. Type in the left-hand side with a calculator and see what it should be. Natural log of 1.1364. Divided by the natural log of 1.008. We get about 16.047. Remember what the question was asking. When is the population of India going to be about 1.6 billion, according to this model? What is x? X is how many years after 2023? So about 16 years from now, according to this model. So 16 years after 2023, that's 2039. And that'll be our answer. The year 2039, the population will be that big, according to the model. And if we plug in 16, that's a great way of checking our answer, right? This function is f of x equals 1.408 times 1.00x to the 008 to the x. This blue thing is what our function looks like. And when x is about 16, look, we're at about 1.6 billion. So we can see that our answer kind of checks out. That's where we're at here. Let me know if you have any questions. The next video, we'll talk about more properties.